Josh Long, he's a Spring development advocate for VMware. He's a Java champ. He's written already 5 books. He's a Spring blogger. He's a host of the Beautiful, if I pronounce it right, podcast. Yep. And in the end, what I heard, no introduction is needed. I like the title. It's short. You're going to talk about Reactive Spring. And for me, and take this as a compliment, because I like the fact what they wrote, what you're actually going to do. I see you a bit, to me, with no tech background, as the Willy Wonka of Spring, because you're saying, like, if it's all difficult, if it's all a lot, don't worry, because Josh will take you by the hand, explore and guide you through your words, the wacky, wonderful world of Reactive Spring together. So, ladies and gentlemen, happy to have him. Josh Long, take it away. The virtual stage is yours.
Thank you. Thank you so much. Good morning, everybody. Let's see. Here we go. Share my screen. We don't have a lot of time, friends. As always, we don't have a lot of time. So I encourage you to take note of these slides right here. This is arguably the most important set of slides you're going to see in the next hour and whatever time. We have like 70 minutes. Is that true?
You're the last speaker. So indeed, you have like an hour, a bit over. So as long as the people are excited, you do your thing.
Okay, thanks. So we don't have very much time is my point. We can't stay here all night. Whoa, that I would love to. So please take note of this slide here. We have the Git coordinates. We have my online coordinates. Should you have questions, when ineluctably you do have questions, don't hesitate to reach out to me. I'm there for you. Happy to engage, happy to answer questions. And of course, the Git coordinates are pretty important. We're going to go through a lot of stuff today. The goal is not so much that you remember everything that we've ever done. It's that you remember what is possible and that you'll just be able to follow along at your own leisure later on, your own discretion. So please don't hesitate to do so, but not now, of course. Now, normally the conference, I would tell people, don't do this now because you'll saturate the Wi-Fi and you might jeopardize my demo. If there is a silver lining, the one silver lining to this crazy, crazy upside down year is that, of course, you're not going to saturate my Wi-Fi. So, go for it. Have at it. It's fine. But don't worry about the code too much right now. That's what I'm trying to say. We want to keep our focus on what's ahead of us. So we're going to talk about reactive programming today. Obviously today, I was just giving a great introduction, but just briefly, my name is Josh Long. I work on the Spring team. I've done some training videos on all sorts of different topics. I have a book I wrote in 2017 called Cloud Native Java, which is all about how to build applications that survive and thrive in the cloud in terms of Spring Boot, Spring Cloud, and Cloud Foundry. I have a podcast. I have a blog every Tuesday called This Week in Spring. I have a screencast series that goes out every Wednesday, or there's something usually every Wednesday. For example, just this morning, Wednesday, about 9 hours ago. So keep in mind, it's 10 o'clock here, and I'm still finishing my first cup of coffee, but I released a video at 1 o'clock in the morning on Kotlin, right? So there's that. If you go to spring.io for such a video, you'll find a video on Kotlin, for example. And of course, I have a book that was just released, and this is in every Amazon market that you can find, or on LeanPub. If you're buying the printed version, go to Amazon. If you want the digital version, go to leanpub.com. And this book is all about how to build applications that survive and thrive using reactive APIs. It's built to, it's designed to give us a way to describe reactive applications, reactive programming with Spring. Now, keep in mind, this is what we're going to talk about today. Is we're going to talk about reactive APIs. Keep in mind, reactive APIs aren't something particularly novel, right? They've been around in some form or another for, let's say 12 years, okay? What I think is interesting is this moment in time, the sort of juncture where we find ourselves right now, where now because of the use cases that present themselves when we try and build microservices, when we try and build applications destined for the cloud, we have a increasing demand for IO-centric services. And this is where we start to appreciate the benefits of building reactive applications, because there's two things that happen when you move to services, when you move to a services-centric architecture or services-oriented architecture. The first is you have lots of input and output, right? And so while there are all sorts of different things that you could do on your computer today, anything that requires you to do input and output is potentially a candidate for parallelization or for concurrency. That is to say, when you do input and output and you're sitting on a thread, if you're just waiting for something to happen, there's an opportunity for you to be more generous with your code and to give that thread back to the runtime so that something else in the system can use it. Reactive programming gives you an API to make that trivial. So you get better resource utilization. You get better efficiency, right? It's a better bin packer. You can do more with the same hardware. The next thing that we care about when we move to microservices, when we move to services and cloud-centric architecture, is how easily can one service talk to another? How easily can they negotiate perhaps varying cadences, perhaps varying speeds of interchange, right? that becomes tricky, especially in a distributed system where you have no idea about the cadence or the capacity of another service. And so you need to negotiate that, right? This is flow control, not a controversial idea, of course. Ever since you've had one service in the same network as another, you've had to contend with that. The novelty here is that that's now surfaced as part of the top-level API. So if we understand those two high-level goals, then I think we're just about ready to start writing some software. And of course, my friends, in order to do that, we're going to go to my second favorite place on the internet. My first favorite place, obviously, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It's better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to just build a brand new application, taking advantage of all the latest and greatest. Actually, you know what? I want to encourage you, just as an aside, since we have an extra few minutes and I feel like it's worth the extra investigation, I want to encourage you just to take a look at Spring Boot 2.40 M3. Normally, for the balance of our time, we're going to spend our time looking at the GA 2.34, but 2.40 M3 is compelling for a number of reasons. And while we don't have a whole ton of time to sort of look at that, I do want you to kind of to take a look at that when you can. And I actually wrote a little project. If you go to my github.com, you'll find there's a project called WebFlux -actuator-GraalVM. And basically, this is just a stock standard reactive application. And we're going to investigate the concepts that underpin these this application today. But what you need to understand is that there's an application. It has proxy bean methods equals false. Let me make the font much larger. I just appreciate that. Okay. It's got proxy bean methods equals false. It's got some. It's got a thing that's going to write some data to the database. So the application starts up, and there's an event, and then it uses the database client. It creates a table, saves some data to the database, finds them, and then prints them out. There's a Spring data repository, and there's an entity, and there's a REST controller, and there's another REST controller. This one's a slower one. And these endpoints all are designed to demonstrate some things that are now in Spring Boot 2.3 and Spring Boot 2.4. The first of which is that this application has Graceful Shutdown. So basically, when you run your software in a cloud environment like Kubernetes, it's very typical for a pod to be killed by the platform and for the platform to spin up another pod in some other place. And the only issue with this, of course, is that if you've got any existing in-flight transactions, you run the risk of having the platform interrupt those transactions. So what Graceful Shutdown does is it allows you to shut down the application, drain off any existing activity, and then actually shut down the application for good. That's one thing that's very nice. Another thing that you care about when you build Kubernetes applications is the concept of liveliness, which is to say the Kubernetes notion of, are you still alive? And readiness, which is the Kubernetes notion of, I've just started up, am I ready to actually start handling traffic, right? Well, now there's two actuator endpoints that are provided for you out of the box. So you can configure your pod to have a pointer to the readiness and liveliness probes. The other thing that's nice about this version is that because I've done this, right? I've done this right here, this version, this proxy bean methods, I am in a very interesting position now because I can take this application and I can compile it, right? So if you look at this code here, we don't really, all this other stuff, I'm just, setting up some color coding for the output. I'm deleting target. I'm creating an output text, I'm just creating a native image directory. I'm unpacking the jar that was built, right? I'm doing all the stuff that you need to do to build a jar, and then I'm unpacking it to I'm unpacking the jar and putting certain things in certain directories, using that to build a class path text file, or a variable rather, and then I'm passing all that into the GraalVM native image. And this is really the only part that matters here, is this native image bit. If I run this command here, assuming I have all these little environment variables there, I will get a native application, a native binary. And this is ideal in a cloud environment because now I can scale the application up quickly. It takes very little memory. It takes almost no time at all to start. And then if I wanted to, I could go a step further. I can actually have Spring Boot create a Docker image for me. Now, this is another feature that's nice in Spring Boot 2.3. I can take my Spring Boot application with no changes at all. I don't have to do anything, actually. I could just do this with 2.3. If I went to start.spring.io right now and I hit generate, this would work as well. I can actually say maven spring-boot:build image. And that would work. But the difference is that with this one, I've got this extra configuration here, and I'm telling it to use the Cloud Native Computing Foundation's Paketo project to generate a build pack to then turn my jar into a Java runtime, into a Docker container that has everything needed to run my Java application. And you can use Paketo for Python and for Ruby and for .NET and Go and everything else as well, but we just support it out of the box for our Spring Boot-based Java applications. If you use this build pack, however, and you enable this environment variable, you're going to get a native image inside the container. So imagine that. You've written your Spring Boot application, got native code, you run Maven Spring Boot build image, now you have a Docker container that contains your native application. So very, very interesting possibilities, right? And then you can publish that Docker image to any container registry. You can then kubectl apply it to, to get yourself to production. You can create a deployment, and you're off to the races, right? So if I go to the target directory here, and I've already taken the time to compile this because it does take a few minutes, right? This is not a trivial process. I've got an 85 megabyte binary. This isn't a jar though. This is a machine processor architecture specific binary. And it starts up in, let's try that again. That was very slow for some reason. Oh, it's probably because I'm being recorded. Oh, that's a little bit better. Okay, there you go. 0.129 seconds, right? And this is for an application that has the actuator. It has a SQL database that I'm embedding, by the way. I'm actually starting up embedded H2 here. And it's got a web endpoint. So, if I go here, localhost, what is it, customers, I think? No, what did I call them? Reservations? There you go, right? So there's my 2 records. So you can do amazing things with the new Spring Boot 2.4. I encourage you to take it out, take a look, and take a look at the Spring GraalVM project. This is not yet GA. This is the other thing that enables the native image support that we've just demonstrated. Very, very interesting opportunity. Now, that said, don't save all that. Thank you. No. Good. Okay. That said, I think I'm going to stick with the defaults. That's just saying, I want to use the GA bits. That's fine, right? So what I'm going to do is I'll go to my initializer. I'm going to build a reactive web application. I'll use Lombok. I'm going to bring in the R2DBC support. R2DBC is the abstraction for building SQL-based data access in the reactive world. And then I'm going to bring in a binder, an implementation for R2DBC. So R2DBC is to reactive as JDBC is to slow blocking synchronous APIs. Okay, and then I'll bring in Postgres. And I've just taken something. Reactive Web, R2DBC, Postgres, and we want Lombok. And we also want our socket. Okay, so we're going to call this service. And I might bring in Spring Security just in case. We might comment it out. I don't know if we'll have enough time, but you never know. We could, right? The other thing that we have here are the choices of Java. Now, of course, my friends, we have before us 3 checkboxes, but really only 2 choices. And I want us to just sort of reflect on that. Let's stew in the contradiction, the paradox of having 3 checkboxes, but just 2 choices. You see, friends, it's late 2020, and in 2020, there's no reason ever to be using Java 8. Java 8 is long behind us. It's way in the rearview mirror. We shouldn't be using that in production. Trust me, you don't want to do that. There's no reason. It's technically and morally inferior. It's technically inferior in every way. It's slower, it's less feature-rich, it's less secure, less robust, etc., less performant. I mean, it's just not a good idea technically, but it's also morally inferior. Friends, it's a morally bad choice. Do you want to have that conversation with your children where you have to tell them you're still running an ancient, creakingly old version of Java in production? I don't think you do. I don't think you do. You're not gonna enjoy the look of despair on their tiny little faces when you admit to that. Okay, don't do it. Use Java 11 or later. Java 11 is the current long-term supported version of Java. It's awesome. Lots of great stuff in there. You can also use Java 15. Java 15 is a current supported version of Java. Now, granted, it's got a 6-month release cycle, so you'll be obligated in 4 months if you want to avoid having to pay support fees to move to Java 16. But this isn't really a problem, friends. This is not a problem of actual concern. It's nobody's holding your arm behind your back and saying you must use the faster, more secure, more stable, nicer version that's completely backwards compatible. I'm just saying it's a privilege. We get to use these nice new versions of Java, and we don't have to worry all that much about how that works. So let me just make sure that I am using that right now. So I have a bunch of Javas on my local machine. I use something called Sdk Manager. And Sdk Manager makes it trivial to switch from one version of Java to the other. So let me just make sure that I've chosen this for the moment instead of Growl as my default. I'm going to use 15.0. All right, good stuff. And I'll make it default as well. Actually, is it default? Let's just see what Java says if I go here. It is the default. Never mind. Oh, that was for naught, friends. Okay, so we're going to hit generate. That'll give me a zip file. And we'll open that up here. Okay, making the font as big as I can. Alrighty. C downloads UAO service.zip. Oh yeah. Okay. Oh, you know, the biggest pity is I can't zoom in anymore. You know, it occurs to me, friends, you might not be able to see this. Let me just make this a little smaller. Okay, hopefully you can all see that better. Okay, so we have a new application. And this application is just a stock standard public static void main Spring Boot application. Nothing all too fancy about that. I'm going to make my font a little, I just really want people to see this. There we go. So it's a public static void main application, nothing all too fancy. We're going to use hopefully everything in the build, but we don't know. We might not. So let's comment out some of the dependencies that we don't need just yet, including but not limited to Spring Boot Starter Security and the corresponding security implementations for our socket. So there's that. Okay. Goodie. Okay. So there's our build. I've commented out our socket and Spring Security. Well, no, I've left our socket, but I'm not going to use it, right? We don't need this as well. So there we go. There's my revised build file. I'm going to hit reload. And with that, I now can write code without concern that I'm going to inadvertently start up something I don't need. Now, again, we're using Java 15. Java 15 is awesome. So there's a lot of really compelling features. For example, var message equals hello world. See, look at that, multi-line strings. It only took 25 years, but they're here. And we've also got var, right? Auto variable type inference. So var, whatever, var x equals arrays dot as list, right? Lots of nice features here that I encourage you to check out. But for our purposes, it's just a really nice runtime. So what we're going to do is we're going to build an application that writes data to the database. And we're going to start, as usual, with just our domain model. So we're going to write to a SQL data store. In order to write to a SQL data store, we need to specify a connection string. So we're going to use an abstraction called R2DBC. Now, R2DBC is a reactive relational connectivity abstraction, right? Reactive relational database connectivity abstraction. And when you connect, it looks kind of like PostgreSQL. It looks like JDBC, right? And so if you go here, username, orders, and then password is equal to orders, and voila, there's my connection string. Nothing all too fancy there, right? Now, once I've got that, I want to describe a Java object that maps to a single row in the database. So I'll create an entity, if you will, here. It's an entity with a single field for an ID and another one here for a name. And that's the essence of what I'm trying to express. But of course, I can also use I want to synthesize getters, setters, toString, equals, hash code, etc. So I'll use the annotations here to get that done. And then finally, I want to create a repository. I'm going to create a repository like so, extends reactive CRUD repository. And this is just an object that's going to manage the tedious, soul-annihilatingly boring read, write, update, and delete lifecycle of my data. Now, this done, I can now write some sample data to the database. So I'm going to create a sample data initializer, right? So this is just going to be a Spring Bean that listens for an application context event and writes to the database when the application is ready, okay? Now, this is just a callback. It's just an event. And in this event, in this callback, I'm going to need, of course, my repository. So I'll inject my reservation repository. And I want to inject it into the constructor. So I can tell Lombok to synthesize that constructor for me using the required args constructor. And that done, I can create some names. And so what I'm going to do is I'm going to create a reactive stream of names. I'm going to use this type called Flux. We're going to talk about Flux and Mono and all these things in a minute. But let's just create the stream of names, okay? So we're going to list people on the Spring team. There's, of course, Stefan, right? There's, of course, Madura. There's Violetta and Olga. And who else do we have? Spencer. I'm on the Spring team. I count, I guess, so I could add myself there. Who else do we have? Yushin. There we go. And I'm sure there you go. Right there we go. So there's a few people that are in the Spring team. Ria as well. So there's some names. Now these are names. These are things that I want to turn into actual records in a database. So I'm going to visit this reactive stream of names, which kind of looks like a Java collection or a Java 8 stream. I'm going to say names.map, and I'll map each new name into a reservation. And that gives me a reactive stream of reservations. And then I'm going to map each one of those and write it to the database. But the thing is, if I do just map, if I just do this, .save, what happens? Well, if I call .save, save returns a mono. Can you see that? A mono of reservation. And so the behavior of map is to accumulate the output of my Lambda into a container type. In this case, it'll be a publisher of Flux, right? So if I do that, I'll get a flux of mono of reservation. Nobody wants a flux of mono of reservation. That's entirely too many reactive stream types. So what I want to do is I want to unpack that intermediate type here. Okay. There we go. So there's my rewritten thing. But in order for that to work, I need to change the operator that I'm using here. I'll use flat map, right? Flat map helps me flatten these two asynchronous streams. I've got reactive types inside of reactive types. I want to flatten it one level down. I want to smoosh down the asynchronicity, basically. I want to just take the outermost layer of reactive streams and flatten the innermost ones. Just like the curve, we want to flatten our streams, right? Very important. So that done, I can turn this into a Lambda. And that's basically the entire pipeline. I've described a pipeline that has names that are going to get turned into reservations that are going to be saved in the database. But if I ran the code as is right now, you would find that nothing's actually happened. I need to actually trigger the pipeline. And you do that by subscribing. You say subscribe. So, and then here's the output, and you can print it out, and then voila, okay? There's the entire stream. That's the result, etc. Now, when I subscribe, I'm actually triggering the pipeline. I'm turning on the faucet, if you will. I've connected the pipes in the pipeline, but now I'm turning on the faucet. Subscribe is very important. Otherwise, this pipeline is just inert. Nothing happens. Nothing will be reflected going over the wire. There will be no bytes conducted from my local machine to the database, etc. It's just a pipeline. It's just Java code that has strings and variables and all that stuff. Nothing happens. And so it's very important that you subscribe. But there's no reason you couldn't have defined this today and then left the Java program running and then run this pipeline tomorrow. You can hit subscribe tomorrow. So there's a difference between execution time and assembly time, right? Assembly time is when you create the pipeline. Execution time is when you actually run the pipeline. And there's a delay there. There's a gap. There's a bit of disconnect. And that means that you can do things in between when you first start defining the pipeline and when you actually execute it. Or rather, more importantly, the framework can do things for you. So we've been building this pipeline, and what I wanted to show you is how easy it is to do this, to use this API. In fact, if you kind of just turn it all into Java 11 auto type inferred variables like this, right? You don't even know it's not Java 8 streams, right? And in fact, if you go a bit further and you string these things together, it's hard to tell it's not even JavaScript, right? This is actually a very, very concise representation of my code. So what have we actually done? Well, we're using this type called Flux. Even though it looks like a Java stream, it's not. It's a reactive type, and it comes from a project called Reactor. Reactor is the library that underpins our efforts in the Spring ecosystem to support reactive data flow and composition. Reactor builds on top of a library called the Reactive Stream Specification, which provides 4 very simple types. And you can see these types here. Here, right? Publisher comes from Reactive Streams. So org Reactive Streams publisher will publish data asynchronously out of band at a separate time to a consumer. That consumer is a subscriber. The subscriber gets each new record in the onNext method. When there are errors, if there are errors, they are delivered on the onError method. When the subscriber has reached the end of the data that it gets to process, the onComplete method will be called back. And these are the three basic lifecycle methods that you're going to deal with for most of the lifetime of your application. What you will deal with at the very beginning of your subscriber, at the very beginning of the lifetime of that subscriber, is this thing called a subscription. And this is arguably one of the most important types, which is why we talk about it now. A subscription represents the link between the producer and the consumer being the subscriber, the producer being the publisher. It is the thing that the subscriber can use to either request more data of the publisher or to cancel the processing of the data altogether. Very, very important here, right? If I, as a consumer, am getting overwhelmed, the worst thing that you as a producer can do is just to keep handing me things to do, right? So I want to be able to push back. I want to be able to say, no, I can't handle anymore. Please, no more, right? And so that's what's happening here. I can request 10 records, and then I won't get anything more until I request another 10 or 1,000 or whatever records. You can request as much as you want, but only so long as you're sure that you can handle as much as you've requested. So if somebody gives you, 5 billion tasks to do, you're going to be very overwhelmed. You'd much rather have one at a time, right? Same thing for a computer. Give the subscriber just as much as it can handle in one fell swoop without being overwhelmed. If I just am no longer interested in doing the work at all, if I just want to say, okay, never mind, I've just abandoned this work altogether, then I can cancel. This is flow control. We talked about this earlier. This is one of the things that you care about when you're trying to establish more robust services. You might also hear it inadvertently or sometimes interchangeably referred to as back pressure, right? It's the same thing. It's this idea that I'm going to push back on the producer so as to ensure that I, the consumer, am not overwhelmed. Very important. And all we've done is we've just surfaced these types as part of the Java API, right? Again, flow control is something you've had to deal with ever since one computer talked on the same network as another. Not a big deal, right? Not a big deal, not a big thing. It's just nice to have it as part of the API. Now, I say that there are 4 types in the Reactive Stream specification. The fourth one is called processor. A processor is a bridge. It's a source and a sink, a producer and a consumer, a publisher and a subscriber. And that's it. That's the 4 types. If you understand those types, congratulations. You're certified reactive. Go to Silicon Valley, raise $1 billion and throw it all and waste it all on stupid parties. You're ready, right? You're ready to be part of the Silicon Valley scene. That said, I think we can agree these reactive stream types kind of boring, kind of basic, right? They're very trivial. And so we have 2 types coming from Reactor. One of them you've already seen, that's Flux, right? A Flux is a publisher. It ultimately implements publisher, but it has a lot of code in it. And this code supports operators, things like map and flat map and filter and, on back pressure and error and composition and sorting and all this kind of stuff. Look at all this code, just so much code, stuff I don't want to write. 2,270 lines of code. We've also got a mono. So a mono is yet another publisher, but it produces at most 1 value, and it can produce 0 to 1 value, whereas a Flux can produce 0 to n, where n is potentially unbounded. So we've got these reactive stream types. We've got our data in the database. Let's now actually consider what we want to do. Well, I have actual data in the database. One of the things that you can do is you can create a service, right? You can actually have a service that does transactional work. And that service could be pretty trivial, right? Class reservation repository, reservation service. And this service is going to depend on my repository. So I'll say reservation repository. And the service is just going to write data to the database, but it's going to do so in a more coarse-grained way. It's going to have a business method that'll take a bunch of names and return all of the objects that it's been given, right? So save all string names. And what I'm going to do is I'm going to say return this.reservation repository at save all. Or better yet, I can actually I can take that logic that we just created earlier. We'll say flux.just from array names. I'm going to take each one of those and turn it into a new reservation, like so. And then we're going to save it. We're going to say flat map r this dot reservation repository at save r. Now, suppose I wanted to also do some validation, right? I want to make sure that when the application completes writing all the data to the database, that we also validate what we've just done. And so I want to now, on each write, I want to also validate the data. So I'm going to say, run this assertion about each record. I'll say, each record must start with a capital letter. So get name car at 0 is got to be a capital letter. So character is uppercase, right? There we go. Very simple. The name must have a capital letter. Okay. Now, very simple logic, right? Not a big deal. You can see what's happening here. I want to make sure that either all of this data gets written correctly or none of it. So, of course, I can use add transactional here, right? Spring has this annotation called transactional. You can also use the transactional operator, in which case you can wrap a lambda inside of a transaction. But the important thing here is to consider what we're doing. Remember, reactive types move work from one thread to another. There's no guarantee that this line here will execute on the same thread as this, and that will execute on the same thread as that. Threads can change underneath you all the time in Reactive API. And it doesn't matter because we're not writing threaded code, we're writing reactive code, and so we still get much more safe, much more deterministic behavior if we stick to these operators. That said, it does introduce some risk. It does introduce some concerns that you might have. For example, how do I use transactions which have historically been based on thread locals if I can't be sure of the thread on which this reactive pipeline is going to execute? Well, behind the scenes, we're taking advantage of something called a context, okay? And so you can do this as well, right? We have this thing called a context, and the context is just a key value thing, right? Blah, 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 context, okay? You can change it, you can use that as well, but the benefit for us is that this context is a way to propagate data along the life of the reactive stream. We use it to make sure that we stash the current state associated with the current ongoing transaction. So you don't have to worry about it. Add transactional works just as you expect it would, right? Even though it's not using thread locals anymore. It's changed to support reactive APIs. Okay, very convenient. Now we have the service. Okay, the next thing I want. What is the next thing I want? Well, I've written all this data to the database. Let's use our service. First of all, reservation service. Okay, reservation repository. Good. And what I'm going to do is I'm going to take all these names. Here we go. We'll say this dot service dot save all. And then we're going to take all that data. We've already written the data to the database. I want to see the transaction in action. But before I do that, I want to clean up the state of my database first. So I'm going to say this dot repository dot delete all, right? And then once that's all deleted, then and only then I want to process the names. I'm going to say write the data to the database. And then and only then I want to say repository.find all, right? And then finally I'll subscribe, okay? And here I'm going to print out the results as they arrive. So again, I'm running asynchronous code. I'm running deterministic concurrent code, right? But I don't have to worry about that. But I did create one section that's enveloped in a transaction. So let's say I lowercase my name, okay? That should, if we understand everything, everything's going to be deleted. And then either all of these 8 records or none of them will be written. And then when we do find all, we'll get all the results, but there should be nothing left because we have a bad record. So let's see what happens. Let's run this code. Connection refused. Did I inadvertently list? Oh, hey, brew services start. Okay. Good. So PSQL U orders. Not MySQL, select all from reservation. Good, we've got that data. Let's delete it. actually, it'll get deleted anyway, but delete from reservation. Okay. Run this again. Okay, there's our data. Now what? The name must have a capital letter. See that? So our logic is kicked in, our validation logic is kicked in. So it's working as we'd expect, right? That's good. Now, if we go to our database, nothing is there, right? So it didn't write a single name. It didn't write 1, didn't write 3, it didn't write any of them because there's a transaction. That said, if I go back and fix the name, we should see all these records written to the database. Port 8080. What is on port 8080? Oh, this thing, of course. Okay, there's our data. There's our 8 rows. There they are on the console. Everything's working fine. So transactions work. SQL-based data access works. HTTP, we don't have an HTTP endpoint. Let's build an HTTP endpoint. So that's easy enough. We could use @REST controller. We could say class reservation REST controller, no problem, right? And we can inject the reservation repository there. And that's fine as well. And then we can create an endpoint here, reservations, and publisher of reservation, get that. Let me say return, this type reservation repository, find all. And there's my endpoint, right? That works just fine. That's something that might look familiar if you've ever used Spring MVC. Keep in mind, though, this is not Spring MVC. This is Spring WebFlux. It's a brand new reactive web first runtime. This API is familiar. I like it, but I have also really quite grown to like the functional reactive style. And the way this works is you create a router function, server response routes. Okay, build dot get / reservations new handler function, and I'm going to return a server response dot okay.body. And in order to satisfy this dependency, I'm going to need to inject my collaborating object there. Voila, there's my entire API. Now I can clean this up a lot. I can get rid of the static I can add static imports rather, etc. And now my whole HTTP endpoint becomes this one-liner, and it's a fluid builder DSL, so I can actually add other endpoints here without complicating the code. I don't have to declare whole new classes, etc. So it's very nice, and it's a choice. You don't have to do one or the other. You can mix and match. You can do both. Okay, so now if I run this, I've got a reactive application that starts a web server that starts listening for data requests on port 880 that writes to a SQL database, and I can hear you all saying, so what? Who cares, right? Like, I could have done this yesterday, Josh. I don't need reactive APIs to write 8 records to a Postgres database in 2020. We could have done this using servlets and JDBC just fine yesterday. And to that I say, you're right, absolutely, that's true. But what I'm not really trying to persuade you just yet of the superiority of reactive programming. What I'm trying to convince you of is that for the most part, working with reactive APIs is not any more difficult than it was before, and you can do all the things that you would have done before. We've just created a stock standard trivial reactive application that talks to a SQL data store that has an HTTP endpoint that does JSON and does transactions. Cool, right? Nothing has changed. The code is trivial. Actually, there's less code here than I bet you would have written for a lot of things, right? Consider that this is just a demo. This is not going to be in your production code. So really, that's it, right? There's my entity, my repository, my service, and my HTTP endpoint, right? So, not a big deal. Something's going on down. I'm 12 floors up in San Francisco, and yet sometimes you can hear road noise. Weird. Okay, so we have all of this. We have our pipeline set up. Well, I've demonstrated to you that you've got parity. You've got the ability to do what you could do before. Let's talk about some use cases where you really benefit, okay? So first things first, I want to build a never-ending service. I'm going to build a service that emits data in a kind of constant fashion. So I'm going to create a greeting service. And this greeting service is going to provide a reactive stream of greeting response given a greeting request. Okay. And we're going to use the request with a name to produce the response, like so. And the response will have a message. Now, I'm going to use Lombok, of course, to synthesize the getters, the setters, the toString, etc., and make short work of all that busy logic. And what I want to do here is I want to just create a simple bean that's going to return an infinite stream. So return flux.stream.generate. Okay, new supplier. And this is just going to return a new response, new greetings response. Hello, request.getName at instant. Instant.now. Goody. Okay. And of course, I want to delay elements. So I've got this reactive stream. And I want to delay the data as well. First of all, I want to limit how much I take. I want to take just, let's say, 100 records. And then second of all, I want to delay the elements. I want to limit the speed. I'm going to slow it down artificially so that we can synthesize something that's long running, something that'll take time in the future. So I've got a service, and now I want to create an endpoint to make this data available over the internet. And I've already used HTTP to create my reservations endpoint. I could, I suppose, use HTTP here. I could try and do something with server-side events. That might work. But of course, that's it has all the limitations of HTTP, which is to say it only understands request response, and it's textual, and it's very inefficient as a payload and so on. I could use WebSockets. WebSockets don't have headers, though. That's a little awkward, right? How are you supposed to do on-the-wire, out-of-band information like a token, right, for security? So what I want is something that is operations friendly. That is to say that it has information about the state or the health of the service for my service. I want something that is reactive. That is to say it understands true back pressure, right? With HTTP, I can only cancel, right? Have you thought about that API earlier as we've been looking at these protocols? If I have a HTTP client that connects to my reactive HTTP service and the client disconnects, what's the best that I can do? Well, I can actually perceive that disconnect and cancel. That's it. There's no way for the client to request 10 records and then request another 10 an hour from now, right? This is the problem. So that's not going to be great. So all I can do is I can cancel. That's one-time back pressure. I want true session resumption and cancellation, right? And so I can get that, and I can get operations, I can get reactivity, I can get different message exchange patterns beyond request response, I can get headers, I can get binary payloads, I can get all sorts of good stuff by using a protocol called RSocket. Now, RSocket was developed, it was forged in the fires of production at Netflix and Facebook by engineers there. And the result is something that is really compelling, right? It's a very, very interesting protocol. It's being used at scale by Facebook, Alibaba, and a number of other organizations. And the Spring team, along with Facebook and Netify and so on, are the sort of main contributors to this technology. It's now part of the Reactive Foundation, which we co-founded as well. So this protocol, very interesting. There's a lot of different clients for it. There's different implementations for the different languages, including Java, C++, and Go, and JavaScript. Well, of course, the Java implementation uses Project Reactor. So it was trivial for us to integrate it into Spring. And so that's what we've done. I'm going to build here a regular Spring controller based on RSocket, right? So RSocket controller. And I'm going to use my greetings service. We'll inject that here as always. At message mapping, greetings, publisher, publisher, greetings response. Okay, and we get a greetings request. Return this.greetingservice.greet request. There we go. That's the entirety of the code that I need to write to be able to create an RSocket endpoint. It doesn't have URIs so much as destinations, okay, or and you can see we've got that. There's even destination variables, right? So I can say ID, for example, that kind of thing if I wanted to, in which case I would say destination variable string ID or integer, right? I could do that. And, you know, it works very similar to Spring MVC controller handler mappings, and it has a lot of the same benefits of it, right? So I've got an endpoint, in order for this to create an actual RSocket service, I need to tell my API to set up an RSocket port. So I'm going to say RSocket server port equals 8888. Now with that done, I can talk to my RSocket service a couple of ways. I can use the RSC command line. RSC is a kind of like curl for RSocket endpoints. So I can say that I want to call TCP localhost 8888. I need to tell it what kind of interaction I'm doing. So in RSocket, you have 4 types of interactions. You have request response, where you have a single value that comes in and a single value that goes back out. You have request stream, where you send a single value in and get a stream of values back, which is what we're doing, by the way. So -- stream. You have multiple values in and multiple values out. That's called channel. And you have fire and forget. So you can send a single value in and then ignore the response. And this is a very common thing in messaging, right? We care sometimes about the acknowledgement of the request, but sometimes we don't. Sometimes it's just, if you got it, great. If not, that's okay. There's more coming, right? So for example, metrics or telemetry or logs or, heartbeat events. If you miss one, who cares? It's not the end of the world. Frames in a video, right? There's most protocols, most of the services that need these kinds of things have error correction built into it, right? And so we may not need all that. Fire and forget is very useful, but it's just not easy to do with HTTP. It's very natural to do it with something like Kafka or RabbitMQ or ActiveMQ or whatever. Okay, so stream. The endpoint, the route is called greetings. And the data that I'm going to send in, we can use serialization here and content negotiation. I'm going to say the name is equal to open lava, okay? And when I do that, I get back a stream of responses. So there you go. There's my data coming back. And remember, this is binary data, but since I sent in a JSON payload, it's converting it back for representation on the console into JSON, okay? So that's one way to communicate with your service. Now, of course, what I want to do is I want to build a client. So we'll go here, and we'll build a client. We're going to use the reactive web support. We're going to use Lombok. We're going to use Spring Security. And I need RSocket as well, right? So we're going to build a client. We're going to hit generate. UAO client.zip. And this client will just act as a client to our remote service. So I'm going to build a new reactive application. The endpoint, well, the first thing I'm going to do, I'm going to connect to my HTTP endpoint. So I'll say I want to build a reactive endpoint. This will be my HTTP client, okay? And I'm going to build a bean, application listener, application ready event, ready, and whatnot, okay? Now, what I'm going to do is I'm going to inject here my reactive non-blocking HTTP client to make calls to that downstream HTTP service. Now you remember, the service is just reservation. So I say localhost 8080 / reservations. I'm going to take the data that comes back. I'm going to turn it into a stream of reservations. So I'm going to turn the Java data into these Java objects, the JSON data into these Java objects. So I'm going to do something terrible, something that you should never ever do ever, not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So that's not great, right? Don't do that if you can avoid it. And I'm also going to take my reservation down here. Okay. Good stuff. Okay. Now, we're going to take the data that comes back and we're going to turn it into a reservation. And I'm going to just log it out. I'll log out the results. So system out print line. Okay. All right. So there's my reactive non-blocking client call on the wire. But consider what I'm doing here. I'm making a network call. I'm getting back a reactive stream of reservations, right? And then I'm subscribing to the results. What if something goes wrong in the service? Well, this is where Reactor and reactive programming gives us a leg up. It gives us an advantage, okay? I can actually say, oh, well, if something goes wrong, I want to retry, okay? I want to retry. When, and I want to do a back off, right? I want to try 10 times and then wait 1 second longer for each backoff, right? So that's retry. I can actually tell it to automatically retry the request. Very trivial. What if something still goes wrong? Well, I can say, oh, well, if there's an error, then I can tell it to look for, let's say, this error. And when that happens, I can decide what gets returned. So here I just return an empty stream, maybe, right? If there's a particular exception that I'm looking for. Otherwise, just do this, right? In which case I'll get to control that. Okay, what if I still have an error and I want to make sure it doesn't hang, right? Well, I can use a timeout. And timeouts are a pretty natural way of saying, hey, this is upper bounded. This is never going to take longer than 10 seconds or whatever. Obviously, 10 seconds in the era of microservices, in the era of cloud computing, is an eternity. You don't want to wait that long. But we have 10 seconds. So why would you use timeouts? What's the goal? Most people who use timeouts are doing so that they have a chance to try again, right? They want to upper bound. They want to avoid losing the opportunity to produce a response for their client. So let's say that I've limited the time that I'm going to spend calling this service to just 10 seconds. Well, I mean, 10 seconds, again, an eternity, but to 10 seconds, okay? Now, what that means is that after 10 seconds, this will be done. Whether it's going to be successful or a failure, it'll be done. If it's a failure, I want to try again, right? That's the whole point of a timeout. I want to make sure I don't waste my opportunity to get a response back. So that must mean that I must have a 20-second SLA on the service here. On this client actually has a 20-second SLA, right? Because that means if I fail once and it finishes in 10 seconds, I can try again, okay? Well, what about this service? What about the reservation service? We just wrote it, so we know what it's doing. But let's suppose that instead of just doing what it's doing, it's actually calling another service. Okay, so this one, the client calls the service, and then that service calls another service. Well, this thing, remember, this service, the reservation service, has to respond within 10 seconds. So if it's trying to meet its SLA, that means that when it calls another service, it can only take 5 seconds, right? Because it wants to finish that and then try one more time. This is the problem. Imagine that service downstream now needs to call yet another service. So 2.5 seconds. You see the problem? It's decaying very quickly and we're running out of time. So this is not a good pattern, right? It's not a good pattern to use timeouts. You should have them, but they should not be your first line of defense. A much better pattern to guarantee that you get a response is to use something called hedging. Hedging. Now, in English, we say we want to hedge our bets. You've heard the common aphorism, don't put all of your eggs in one basket, right? Don't invest everything in one option in the market, for example. If you invest in stocks, you should never buy just one stock. Put all of your money in one stock. Don't do that, right? Dangerous, because if that one stock goes down, then you've lost everything, right? So you want to diversify the risk. You want to spread the risk across multiple options. And the same is true here. Let's suppose that I rewrote this to have different hosts, right? And import, okay? And let's suppose that this is parameterized, like so. Okay. And let's move that onto a variable, a method rather. Refactor, extract method. Okay. There you go. So now I can parameterize the host and port. So the host is host 1. And the port is 8080, okay? So, okay, I'm calling host 1. What if that host is down? Well, I can always, to make sure that I get something back in time, I can always ask my service registry. I can go to my service registry and I can say, hey, service registry, how many services do I have out there? And you can use Kubernetes, right? Kubernetes has its own service registry built in. You can ask it for all the services that match a given label, for example. So I can say, okay, host 2, give me host 1, and give me the results from host 2. So I'm calling 2 services at the same time, or maybe better yet, 3 services at the same time, okay? Remember, I haven't launched any of these yet. I haven't subscribed to any of them. I've just got 3 of them. What I want to do now is I want to say, okay, all 3 of you at the same time, go out, give me the data, and whichever one returns the most expeditiously, the most efficiently, the quickest, then I want to keep that one and I want to throw away the other 2, okay? Well, this is hard code to write. Can you imagine how you would write this, right? You're going to launch 3 threads at the same time. You need to somehow do a countdown latch, right, to make sure one of them, whichever one returns, you get that one. And then you need to cancel the other 2 when they're in flight. That's going to be weird, right? It's not going to be easy. In reactive APIs, it's very easy, right? So you say flux.first, host 1, host 2, host 3. And again, not a particularly hard thing to do. So now that's the result that I want to send back. That's Whichever one I get back here, whichever stream I get back, is the fastest one. It's kind of like in POSIX, you have the select function, right? Right. The select function gives you the ability to say, given a bunch of file descriptors, return when the first one emits a byte. Okay. So very, very useful pattern. And the result is, yes, you're making 3 calls. So yes, there might be some redundant network traffic. And of course, you shouldn't use this for endpoints that are not idempotent, right? Idempotent means that you can invoke them without any undue side effects, undue observable side effects. Change to what? Idempotent. Thank you. You should be able to invoke them without any undue observable side effects. That is to say, do not use this for the charge the customer credit card endpoint, of course, right? But very useful pattern. And now I'm guaranteed one of them will return. Maybe the first one's down, right? Maybe it's garbage collecting. Maybe it's slow. It doesn't matter. You need a result. So you call the second one, and you call the third one all at the same time. Whichever one is fastest, you get the response. Again, very easy to express this using reactive APIs. You can see, I don't care about that. You can see we've also got all these operators to make our streams more robust, more efficient, more resilient, okay? So I like these APIs. There's a lot of interesting things that you can do here though, right? You can also do very easy scatter, gather, service orchestration, and composition. So for now, let's suppose that you have 2 types, okay? You have an order, and the order, let's say that the order has a customer ID. So you have one-to-many orders for each customer. And then you have class customer, string ID, and string name. Okay, good stuff. Look at that. So you've got customers and orders. And now I've got, let's say that I've got 2 different services that I want to make a call to, I want to connect to. Well, so now I've got a stream of customers. Okay. To do. I'll leave it to your imagination how we get that. Just make a network call, right, with WebFlux, with the web client there. And I also have I want to say for each customer, give me all the orders, right? So let's go down here, paste that here, and what's the unhappy issue? Okay, there we go. Yeah. So I've got now, let's say that I've got a client, and then we're just going to create the interface so that we know what we're dealing with here. And the client will give me get all customers. Okay. And for each customer, I want to get all the orders. Get customer orders. String customer ID. So now I've got this client, and I want to make a call, get all the customers, and then for all the customers, get all the orders, right? This is an n+1 problem. You can see it's going to be problematic. But at least when we make this call, we can use concurrency. So yeah, we're launching multiple threads at the same time, but we're doing it as efficiently as possible, right? So now what I want to do is I want to say, okay, for each customer, I want to, first of all, I want to get the customer and the orders in the same place, right? My goal here is to create an aggregate type, a new aggregation called customer orders. And again, I'm making calls to, imagine that these are calls to 2 different microservices, right? The orders and the customers endpoint. So it'll be list of orders, and it'll be customer, okay? Good stuff. Very, very simple aggregation. Now I'm going to take each one of these customers, and I'm going to build a reactive stream out of it. I'm going to build a tuple out of it. So I'm going to say flux.zip. And my goal is to take 2 reactive streams and pair them together. So that's what the zip operator does. It takes two streams, takes one from one side, one from the other side, and then creates a new thing called a tuple. So I need to give it 2 streams. So the first stream will just be the customer, right? Mono.just customer. And the second one will be the client. We're going to use our CRM client that we created earlier. That's, we're just imagining it right now. We're going to use the CRM client. We'll say CRM client dot get customer orders for customer.id, right? Okay, so when I make this call, what do I get? I get back a very confusing publisher of publisher. So so first of all, that's flat map, isn't it? I get rid of this and that, okay? And I have a flat map of tuple of customer of order. I don't want individual orders. I want all of the orders. So I'm going to say collect that as a list. And that gives me back a different type, doesn't it? So if I go here, I get a list of orders, right? So now I've got a reactive stream of a tuple, which has a customer and a list of orders. That's basically it. All I got to do now is turn that into my customer orders, right? I map tuple into new customer orders. So a tuple, and I need to create a constructor here. Required all our constructor. Okay. There's this, and so I pass in tuple.get t1, that's the customer. Tuple.get t2, it's the list. And if I look at that, I've got now my stream of custom orders. And again, we know that these streams, these calls, could come from my CRM client, which could be backed by the reactive web client. I could be making network calls to many different services, but because I'm using reactive APIs, there's no problem, right? And it's concurrent, right? I'm doing this at the same time. Great for composition, service orchestration composition. So we can see with reactive APIs, it's easier to compose services and it's easier to build more resilient, robust calls to the network. Now, okay, all of that, just conjecture. Obviously, none of that's going to execute because we have null everywhere. Let's get back to what will execute, right? So we will say get reservation flux, HTTP, localhost, 80, and we're just going to subscribe. That'll be our, okay? There's our HTTP endpoint. We also want to talk to the RSocket endpoint. So I'll create an RSocket requester dot builder. Okay, and now in the RSocket world, there's no such thing as client server, right? You have requester responder. And so either side, once connected, can talk to either side and they can do whatever they want to do. And so you build a client and you build it once when the application has started up. And you can inject that and use it for the rest of the application. And you don't have to specify over and over the host and port, right? So here, I'm going to say rsocket.route greetings. And the data that I'm going to send in is the greetings request, OpenSlava. And the data I'm expecting back is a greetings response. And I'm going to subscribe. System out println. Now notice what we're doing there. We're using these reactive APIs, and because they're all reactive APIs, it's super easy for me to glue them together, to compose them, right? If you think about all the things we've done today, we've looked at transaction, we didn't look at WebSockets, but we could have. We looked at REST, we looked at RSocket, we looked at all sorts of different ways of creating streams of data, and they're all just reactive streams. I did it in memory in the very beginning. They're just reactive streams, right? Oh, port 8080 is already taken. And because they're reactive streams, it's actually easier for me to glue these things together to make them talk to each other. And this is, I think, one of the most amazing parts about reactive APIs. It makes your code easier. You don't have to learn different APIs for messaging, for Kafka, for RabbitMQ, for Kestrel, for all that stuff. You still use Kafka. You still use identify something. No, there. Just you can still use these reactive APIs. You can still use all these same APIs just like before, but now they compose together. I can merge them. I can filter them. I can make calls, distributed calls, and do scatter gather operations against them. And it's easy because it's one kind of stuff. Are you using Kafka? You're using a publisher. Are you using RabbitMQ? You're using a publisher. You're using HTTP? You're using a publisher. You're using RSocket? You're using a publisher. Do you see my point? So now, with reactive programming, hopefully, my friends, you see that there are some interesting possibilities. We looked at how you can do what you've already done with existing APIs and familiar technologies like HTTP and SQL. Of course, there's also rich support for NoSQL data stores. I didn't even show you any of those. We could have looked at well, besides all the SQL data store implementations, we could have looked at Google Cloud Spanner and MongoDB and Redis and Azure Cosmos DB and Cassandra and Mongo and Neo4j and Couchbase and all these other ones that support reactive APIs. We looked at basic HTTP. We could have looked at WebSockets as well. We looked at RSocket. We saw that you get to do basic things that you were doing before, but you also have some new opportunities like RSocket, which is natively reactive. There's no way to use RSocket without reactive APIs. I hope now you've got a sense for some of the possibilities here. Hopefully you've seen that you can do everything you could have done before. You get better, more resource-efficient code. You're actually doing more with the same hardware. You can handle many more transactions with the same computers. You're not wasting RAM or CPU capacity. You get more predictable code because remember, there's only one person who truly knows how to write multi-threaded Java code, and it's not you. That's the important part. I don't know who it is. Nobody does, but it's not you, my friends. That's the important thing to remember. Threads, there's no safe way to write them, right? I saw a great quote yesterday. It made me laugh. I tweeted about it. It was basically, it was from the evolution of Lua, the programming language, and one of the authors said that it is our thinking, our holding, that it is not safe to write programs in a language where A equals A plus 1 is not deterministic, right? Basically, if something as simple as incrementing a variable can fail because of threads, then you're dealing with a landmine, right? So with reactive APIs, you greatly remove the source of those errors, right? And also, you get ease of composition. So you have less code to write, less APIs to learn. You get more flexibility, more robustness, and so on. The other thing that we didn't get to look at, my friends, is the opportunity for using this with Kotlin. Kotlin is a programming language that has taken the world by storm. It's the second most productive, most prolific language on the JVM. And Kotlin gives you the ability to write coroutines. If you understand reactive APIs, the coroutines build on all this. They're literally the same. So there's an opportunity there as well. I want to thank you all for your time, friends. Thank you so much. I hope you're healthy and happy and safe and have a wonderful show. And thank you for having me.
Okay, thanks, Josh. Nice. Very nice. I'm not going to claim, like I said, in my background that I understood a word of what you're saying, but I really love the fact how you bring it. Because even I, who doesn't understand it, was like, yes, let's glue it together. Let's compose stuff. And that's how enthusiastic you are.
If I can do it, you could do it, buddy.
There you go. Actually, I should dive in. I got some tweets from people saying, like, you should also get into this for next year. So maybe I should do some springtime here. I'm looking at the chat right now. A lot of applause coming in. I don't know if you're in hopping right now, if you're looking at the same screen.
I should be, I guess. Yeah, I mean, log in. Are there questions? Is there anything I can do to...
They're getting thanks, chapeau, a lot of things. People were laughing when you said, get your kids on there, get your family on there. Someone said that they have a 9-year-old kid that is already deployed.
Yes. Oh, that's so great. Really? I love that.
So we're inspiring. Someone probably while you were doing this at the end said just flat map it.
Yeah, the more common version of that uses a 4-letter word that I won't reproduce here, but yeah, just flat map that. It's a very common thing to say.
More things coming in. We have a 13-second delay on the chat, so I'm just waiting a bit. If you have questions right now, check it. If not, or you have to go because it's already 8 people, you can rate this speech in the polls, and you can connect with Josh, of course, Starbucks man. Read his book, listen to the Beautiful podcast, and he will guide you through it. But in general, I think everybody's psyched because if you look at the chat, it's going crazy.
I appreciate that. I appreciate all of you. I wish I could be there in person, but hopefully next year, right?
Yeah, let's all look forward to that if we can do. There you go. It was. Let's end with what Martin is saying in the chat. This was absolutely breathtaking. Thank you, Josh.
Oh, thank you. I appreciate it. Can you send me the chat, or I'm not sure if I'm seeing it. Maybe I'm not. But either way, I appreciate it.
There you go. And one person had a question in the beginning that already disappeared because of all the things coming in. Is they were wondering where they could get the Spring T-shirt. They needed some merch.
Oh, this one. I don't know. This one I just printed custom because it's my book cover. But the one that I usually wear, the one that's in my slide, it used to be you could go to store.spring.io. I'm not sure if we still have that. No, it's gone. Reach out to me and I'll see if I can get my European people to send us.
There you go. So connect with him. The T-shirts could be there. Maybe it could be a whole new business.
I don't know. We can't just give them out to everybody, unfortunately. But one or two.
That's true. All right, Josh, I want to thank you very much. You said good morning, so I think you're going to start your whole day. We are wrapping up our day.
Yep.
So
what a wonderful opportunity. Thank you so much.